Welcome to our deep dive, into this fascinating world of crystallization. You might be thinking crystals, pretty rocks, what's the big deal?
Yeah.
But trust me, we're about to uncover how this process, impacts everything.
Oh, yeah.
From the delicate beauty of snowflakes to the effectiveness of, life-saving medications.
Absolutely.
We've got some amazing sources lined up, and I can't wait to just unpack them with you.
It's a process that I think often gets overlooked.
Yeah.
Yet it plays this fundamental role in shaping the world around us.
Right.
From the natural wonders we admire to the cutting-edge technologies that we rely on.
I think our deep dive today is going to be a perfect example of
Oh, that's
this.
sure.
So let's start with the basics.
Okay.
What exactly is crystallization?
So at its core, crystallization is all about order.
Okay.
It's the process of atoms and molecules arranging themselves into these incredibly precise repeating patterns, forming what we call a crystal lattice.
Oh, okay.
Like tiny little soldiers all lining up in perfect formation.
Like tiny little soldiers lining up?
Exactly.
Okay.
And just like a well-organized army is more effective, the specific way these atoms arrange themselves determines a substance's properties.
Right.
Its strength, its melting point, how it interacts with light,
Yeah.
even in how it behaves in our bodies.
Speaking of arranging themselves,
Yeah.
one of the most captivating examples of crystallization, has to be snowflakes.
Oh, for sure.
I mean, how do they form those intricate six-fold symmetrical structures?
It's mind-blowing. It really is.
And every snowflake is unique, right?
Yeah.
Well, that uniqueness comes from the subtle variations in temperature and humidity
Right.
that the snowflake encounters as it falls through the atmosphere.
Yeah.
These tiny shifts influence how the water molecules arrange themselves as they freeze,
Exactly.
leading to an endless variety of stunning snowflake designs.
Yeah.
So basically, each snowflake is like a tiny frozen record of its journey through the air.
That's a great way to put it.
Oh, thanks.
And this idea of environmental conditions influencing crystallization
Right.
is crucial,
Yeah.
not just for pretty snowflakes, but in a whole range of scientific fields,
Okay.
especially pharmaceuticals.
Okay, now we're getting to the good stuff.
All right.
So how does crystallization play a role in the medicines we take?
Well, think about it this way.
Okay.
The effectiveness of a drug often depends on how well our bodies can absorb it, right?
Right.
And that absorption is directly influenced by the drug's crystal structure.
Okay.
The way the drug molecules are arranged determines how easily they dissolve, how stable they are,
Right.
and ultimately how effectively they can reach their target in the body.
That makes sense. I remember reading about lovastatin,
Okay.
a cholesterol-lowering drug.
Yes.
It actually exists in several different crystal forms.
Wow.
And each form has a different level of effectiveness.
Interesting.
That's crazy.
It really highlights why controlling crystallization is a huge deal in drug development.
Yeah.
It's not just about creating a drug that works.
Right.
It's about creating a drug that works optimally.
So how do scientists actually go about controlling something as tiny and intricate as crystal formation?
It's definitely a delicate process,
Yeah.
but there are several techniques that they use. One common method is called seeding, where they introduce tiny seed crystals into a solution
Right.
to act as templates,
Okay.
guiding the growth of larger uniform crystals.
So it's kind of like giving the atoms a blueprint to follow.
Exactly.
Okay.
And just like a good blueprint is essential for building a structurally sound house.
Yeah.
Precise seeding is crucial for creating high-quality pharmaceuticals.
Right.
Another critical factor is temperature control.
Okay.
Even the slightest temperature fluctuation can drastically alter the crystal growth process, potentially leading to unwanted crystal forms
Right.
or affecting the purity of the final product.
Okay.
Yeah, it really is amazing how even tiny temperature changes can have such a big impact on crystal formation.
Yeah.
And it's not just about temperature. Scientists also manipulate factors like pressure, the rate of cooling, and even the presence of impurities to coax those atoms into just the right arrangement.
It sounds like a delicate dance between chemistry and engineering.
It is.
But it makes me wonder, if we're getting so good at manipulating crystals in the lab, how does that translate into real-world advancements?
Well, one area where crystallization is playing a key role is in the development of new and improved materials.
Okay.
Think about high-entropy alloys, for example.
He's right, yes. Those super strong alloys that are made from mixing a whole bunch of different metals together?
Exactly. You might think that combining so many different elements would just create a chaotic mess.
Yeah.
But surprisingly, the atoms in these alloys arrange themselves into these incredibly ordered crystalline structures.
Huh.
And because of this unique arrangement, he's possessed like extraordinary properties.
Okay.
They're stronger, more durable, and can withstand much higher temperatures than traditional alloys.
So they're like the superheroes of the materials world.
You could say that.
Where are these super allies being used?
Everywhere from aerospace and energy production to medical implants and even sporting goods.
Wow.
They're finding their way into all sorts of applications where strength, durability, and heat resistance are critical.
It's amazing to think that something as seemingly simple as controlling the arrangement of atoms can lead to such groundbreaking advancements.
It really highlights how a deeper understanding of crystallization can unlock a world of possibilities.
Yeah.
And it's not just about creating super strong materials.
Right.
Scientists are also exploring how to use crystallization to develop more sustainable technologies.
Now, that's something I'm always interested in hearing about.
One promising area is carbon capture and conversion. Figuring out ways to capture carbon dioxide from the atmosphere and transform it into something useful.
Right.
And guess what?
Wait.
Crystallization is playing a key role in this process.
Wait, so we can actually capture harmful CO2 and turn it into something valuable using crystals?
Exactly. Scientists are developing specialized catalysts that can facilitate this transformation.
Okay.
And these catalysts often rely on very precise crystalline structures to function efficiently.
So crystallization is helping us tackle climate change.
It is.
That's incredible.
It's a powerful example of how scientific advancements can be applied to address some of the world's most pressing challenges.
Yeah.
And speaking of pushing boundaries, there's another fascinating area where crystallization comes into play.
Okay.
Piezoelectricity.
Piezo what?
Piezoelectricity.
Okay.
It's a phenomenon where certain crystalline materials generate an electrical charge when they're subjected to mechanical stress.
Okay.
So imagine squeezing a crystal and getting a jolt of electricity in return.
Whoa, that sounds like something straight out of a science fiction movie.
Yeah.
But it's real.
Oh, it's very real.
Wow.
And it's already being used in all sorts of technologies.
Okay.
For instance, ultrasound imaging relies on piezoelectric materials to generate and detect sound waves.
Uh-huh.
And those tiny sensors in your smartphone that detect motion and orientation are also based on piezoelectricity.
Okay, I'm officially mind blown.
Good.
So how does this squeezing a crystal to get electricity thing actually work?
It all comes down to the arrangement of atoms within the crystal structure.
Okay.
When you apply pressure to a piezoelectric material, you're essentially distorting that structure, causing ions to shift their positions.
Right.
And this movement of ions creates an electrical current.
Oh.
It's like a tiny built-in generator.
So you're telling me that my phone charger could theoretically be replaced by a squeezed crystal?
Well, it's not quite that simple.
Okay.
But the potential is there.
Yeah.
And what's even cooler is that this process is reversible.
Oh, wow.
So you can also apply an electrical current to a piezoelectric material and cause it to change shape.
Wait, so we can make crystals dance by zapping them with electricity?
You could say that.
That's so cool.
And this property opens up even more exciting possibilities. Imagine self-powered wearable devices that generate electricity from your body movements, or tiny implantable sensors that monitor your health in real time.
This is seriously amazing stuff.
It is.
It seems like crystallization is at the forefront of so many cutting-edge technologies.
It really is. It's a fundamental process with endless possibilities.
Yeah.
From the everyday materials we use to the most advanced technologies we can imagine.
Right.
And speaking of exploring those possibilities, let's delve into the world of plastic and discover how crystallization plays a surprising role even in this ubiquitous material.
Plastic and crystals.
Yes.
Now that's a combination I never would have expected.
I know, it's a good one.
But I'm all ears. Welcome back to the show. I'm still trying to wrap my head around this idea that crystals can generate electricity.
It's pretty wild.
Yeah. But now we're going to talk about plastic. I thought plastic was, well, plastic.
Right.
Flexible, sometimes bendy. Definitely not something I'd associate with crystals.
It might seem counterintuitive, but even plastic can have an ordered structure.
Okay.
At the molecular level, you see, plastic is made up of these long chains of molecules called polymers.
Right.
And under the right conditions, these polymers can actually arrange themselves into a crystalline structure, just like the atoms in a snowflake or a diamond.
Hold on. Are you saying that my water bottle is secretly a crystal in disguise?
In a way, yes.
What?
The degree to which those polymer chains are ordered determines the plastic's properties.
Okay.
For example, A highly crystalline plastic will be more rigid and strong,
Hmm.
like the plastic used in a hard hat,
Right.
while a less crystalline plastic will be more flexible. Think about a sandwich bag.
So the next time I'm wrestling with a stubborn clamshell package, I can blame it on crystallization.
You could, but seriously, the ability to control crystallization in plastics is a big deal in manufacturing.
Okay.
By tweaking the processing conditions, manufacturers can fine-tune the properties of the plastic to suit a specific purpose.
So it's not just about making plastic strong or flexible. What other properties are affected by crystallization?
Well, one important factor is transparency.
Okay.
Think about a clear plastic water bottle.
Right.
That clarity is a result of the polymer chains being neatly aligned in a crystalline structure.
Mm-hmm.
If the plastic wasn't crystallized, it would be cloudy or opaque.
So crystallization is the secret ingredient for making plastic both strong and see-through.
It is.
That's pretty neat.
And it makes even more interesting. Scientists are now exploring how to use crystallization to make plastic more sustainable.
Now you've got my attention. Tell me more about how crystallization fits into the whole sustainable plastics movement.
Remember those plastic-eating enzymes we talked about earlier?
Yes.
Well, it turns out that the ability of those enzymes to break down plastic depends in part on the plastic's crystalline structure.
Okay.
So if we can control the crystallization process, we can potentially design plastics that are easier for those enzymes to digest.
So we're talking about engineering plastics that can be broken down or recycled more efficiently? That's a game changer.
Exactly.
Wow.
It's all about closing the loop on plastic waste and reducing its impact on the environment.
This has been an incredible journey into the world of crystallization.
I agree.
I never would have guessed that something as seemingly simple as the arrangement of atoms could have such a profound impact on our lives.
Yeah, it really is remarkable how such tiny building blocks can have such far-reaching consequences.
Right, and who knew that crystals were hiding everywhere, from our snowflakes to our medicine cabinets to even our plastic water bottles?
It's a testament to the power of science to uncover these hidden connections and to use that knowledge to improve our lives and our planet.
I think that's a perfect note to end on. So to all our listeners out there, I encourage you to take a closer look at the world around you and appreciate the intricate beauty and the incredible power of crystallization. It's truly a force to be reckoned with.
Well said.
Thanks for joining us on this deep dive into the fascinating world of crystallization. Until next time, stay curious.
Bye.